but the memories are still in my mind, burning like smoke and fire.
What's up guys, I'm Nishit Tarantula, and today's topic is completely mysterious. Well, the whole physics is mysterious, but today's topic is about something which exists, but it does not exist, and that is dark matter. Right, let there be our solar system, and in the center there's a sun, and it's our Earth, suppose. And I made this orbit complete circular because of the sake of simplicity, but in reality the planets moved in an elliptical orbit around the sun. So for sake of simplicity here, the here the orbit is circular. So due to the gravity of the sun, Earth stays in its orbit and rotates. But if there'll be only one force, which is the force of gravitation of the sun towards the Earth, then Earth would directly eaten by the sun. So to make a balance, there's one more force, which is the centripetal force, which is denoted by Fc. The formula of centripetal force is Fc is equals mv squared by r, where Fc is the centripetal force, m is the mass of our Earth, v is the velocity of the Earth. Wait, suppose our Earth is moving in this direction, okay, with speed v. Velocity is v is the velocity of the Earth squared, and divided by r. The r is the distance from the center of the sun to the center of the Earth, which is the radius, okay? And the force of gravity, and then let's take the force of gravity, which makes it balance. Force of gravity will be equals to gravitational constant times m1 times m2 by r squared, where m1 is the mass of the sun, m2 is the mass of the Earth, and r again is the distance from the center of the sun to the center of the Earth, which is the radius squared. This formula of gravity is given by Newton. It's the universal law of gravity given by Newton. So if you just take this formula and calculate it, you will get that the m will be cancelled out, one m will cancel out the other m, and this r will also be cancelled out. But wait, what's the meaning of squared here? Squared means r times r. If it would be cube, then it would be r times r times r. But in this case, it's just squared, so r times r. If I cut one r here, if I cancel one r here, then only one r will be cancelled. That means it's not now r squared, it's now just r, simply r. And we obtain v square is equals to capital G, which is the gravitational constant, times m by r. Okay, here the gravitational constant as well as the mass are constant, mass of the sun, divided by r, which is the radius. It can give you the conclusion that v squared is proportional to 1 by r, where v is the speed of the revolution of the Earth around the sun, and r is the distance between the Earth and the sun. So v squared is proportional to 1 by r. That means as the velocity of Earth to revolve around the sun increases, the distance increases. And as the distance increases, it simply means the velocity is increased. Alright. Kepler's law. by taking Kepler's third law, by taking the time as t. Hope it's visible. Alright. There'll be a time taken by Earth to revolve, and time is equals to distance upon speed. But how can we know this distance? The distance is actually circular in shape. So here you have to find the circumference of a circle, which is 2 pi r by speed, which is v. If we just squared it, then we'll get t squared is equals 2 squared. The square of 2 is 4, so 4 pi square r squared by v squared. If we substituted it with v squared, then we'll obtain 4 pi square times r cubed, because it was over r, by v squared. Okay, hope you understand why it became r cubed, why it does not remain this r squared. So my answer, because we substituted it from v squared, where r was in the denominator place, but here we took that r here. R squared means r times r, so when we took this denominator in the numerator place with the r, that means we multiplied it one more time, and which gave us r cubed. And that's the way I obtained this. So here 4 pi and I'm so sorry, I made a big mistake. I sometimes make mistakes. It's not v squared here, it's gm. Okay, it's gm, not v squared. I'm sorry, I made a mistake. Here 4 pi and gm both are constant. Okay, so we got a conclusion that time time taken by the earth to revolve around the sun is proportional by r cubed. It means as the distance between the sun and the earth increases, the time taken by earth to revolve around the sun also increases, and as the distance decreases, the time taken by earth to revolve around the sun also decreases. You can also conclude this by an experiment. Just take a thread in your hand and tie one end of the thread with a ball and try to revolve that ball around yourself. And when that ball will gain a high speed, then you'll observe that the ball is moving outwards due to the centripetal force. And that's now using these two, I can show the movement of the total 9 planets in our solar system in a graph. This is the V quadrant. V, you know V. V is the speed of revolution of planets around the sun, and this quadrant is the R quadrant, which is the distance. So the graph will be something like this. Will be something like this. There's a error at this place. It should be curved. I've plotted all the 9 planets in this graph. The Pluto, Neptune, Uranus, Saturn, Jupiter, Mars, Earth, Venus, and Mercury. And you can see here, as the distance increases, the time taken, the speed decreases. Speed is here and the distance is here. Look here, as the distance is increasing, the speed is just this much, but as the distance is only this much, which is of Mercury, then its speed is too high. From this place reaches to this place, it's so high. Now consider that there's a planet inside our sun. Well, there can't be any planet inside the sun, but just assume for this. But just assume that there's a planet inside the sun which is revolving around the center of the Earth. What will be its revolution? So to find out that, let's move on. Thought experiment: there can be a planet revolving around this inside the sun. So there is also a time taken by the planet which revolves inside the sun. Well, there isn't any, but if there would be, there will be a time taken by the mass to orbit the center of the sun. So this formula also applies here, this place. The gravitational constant is constant, but as the experiment says, the mass would not be constant. The mass would be only the one enclosed inside the orbit. That means mass will be reduced. And when the object will come at the center, its speed will be 0. We can express it in such a way. This would be the movement of the planet inside the sun. As it comes closer to the center, its speed starts increasing. This is the quadrant of the speed. Look, as it comes closer, the speed is here, and or the distance. When the distance is this much, the speed is this much. When the distance decreases and comes here, the speed comes here, that means the distance is at this place. This is the distance between the center of the sun and the mass. So this will be the diagram. But let's come on dark matter again. What I said, it exists, but we don't have any evidence that there is dark matter in reality. If we look on the movement of stars in the galaxy, then we can see that all the stars circles the center at the same speed. But here in the formula says that it should not be true. Look here, as we move further from the center, the time taken also increases, but in galaxies this does not happen. The speed is constant and the time taken to revolve is also constant. There's a problem. How it can be? If I shown this galaxy in this graph, then this much part will stay the same, but when we come at this place, as it is slanting down, this part will be straight. it's pretty interesting and pretty confusing that what can be the thing. So it is said that it is the dark matter, which is the invisible matter. Let there be some masses. This is a black hole, which is in the center of every galaxy. Let the stars at this place, star A, B, C, and D. A is the closest, D is the farthest. So what should happen is that A should be fast and should circle this center in a very high speed, and D should be slow and should take more and too much of time to circle this. But this does not happen. Scientists are still finding what is that thing which makes everything balanced in every galaxy. The same in every galaxy, not in only Milky Way. In our Milky Way, Andromeda, and every galaxy in the universe, there can be one thing which can make the relation of all the masses around the center be constant, and that is adding more mass. It's A, it have mass, let the mass be m, then B should have more mass. The more mass means the more gravitational attraction. Gravitational attraction of this and the gravitational attraction of B. And in C, that gravitational attraction will be more, therefore it will be balanced like a seesaw. Scientists believe in parallel universe. There can be universes in such a way that they are parallel to each other like this, and there can be any galaxy, and in the other universe there can be some stuff which is said to be dark matter, which provides this invisible mass to the masses of the galaxies, and as it moves towards the end, the number of dark matter, the amount of dark matter increases, which makes it balance, and that's dark matter, which is mysterious. Thank you guys, and that was the information I gave you about dark matter. I know I was stopping somewhere in places, because by the time when I used to write and used to speak, I becomes too confused. Oh no, what I'm doing, do I have to write or do I have to speak? I becomes too confused, and that's why I was just stopping at places. And one place, I rather than gm I wrote it v squared. That was wrong, I'm so sorry for that. And that was the information I gave you about dark matter, and the video on dark energy is directly coming towards you on YouTube, so please support me. Thank you, bye.